Okay, so page 6. Here we go. All right. So today we're talking about the nature and the number of roots using the discriminant. Okay. So when do we use the quadratic formula? Well, we use the quadratic formula. We use it when the quadratic. Oh, sorry. Thank you. We use it when the quadratic is not factorable, right? If we can't factor it or solve it using the square root method, if we can't factor it or use the square root method, we have to use the quadratic formula. Well, when we first started talking about the discriminant, we learned that the only time we can't factor something is when the discriminant is not a perfect square. Do you guys remember writing that down when we learned about the discriminant? We said if the discriminant is not a perfect square, then we can't factor it. We've got to use the quadratic formula. So remember that the quadratic formula starts off x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And on your test, you actually had some specific questions about the discriminant. What part of the quadratic formula is the discriminant? Yeah, it's the b squared minus 4ac. That is the discriminant. It's not underneath the radical. It just gives you a value, okay? So we're going to fill out some things that we know about the discriminant. So across the top of your tables, I want you to write some words. I want you to write factorable. And then I want you to write not factorable. And I'm just going to abbreviate that as not factor. And I'm going to write not factorable again. And then the last one is factorable. We're going to talk about all the types of numbers. So it says value. Well, I know it's factorable if the discriminant, it's talking about the discriminant. And maybe I even write the formula for the discriminant right here again. B squared minus 4ac. I know that my quadratic is factorable if the discriminant is a perfect square, right? I know it's factorable if the discriminant is a perfect square. Okay. It's not factorable if there is a negative value. If the discriminant is negative, right? We can't factor it if the discriminant is negative. And we also cannot factor it if the discriminant is not a perfect square. So I'm going to write not a perfect square. And we can factor, oh, that's working, if the discriminant has a value of 0. If your discriminant is 0. Okay. So number and types of solutions. So if we can factor it, because it's a perfect square, we know that we're going to have two rational solutions. Two rational solutions. Remember, it's irrational when we have part of a radical left in our answer. Okay. We also know that the solutions are not equal to each other. So I'm going to write solution, and then I'm going to put an X through my, like a slash through my equal sign. And I'm going to give you an example of what I mean by that. I mean, like X equals 3 and X equals -4. That's what I mean by when I say they're not equal to each other. It's not the same value, right? You have two different solutions, two different rational solutions. And the graphs are going to look something like this. They're either going to look like this. Well, that's not a good sketch because I really want it to be -4. Well, you get the idea. I'm not even going to worry about it. So, poop on a stick. So like this, or what's the other way my graph could go? Yeah, it could go down, right? Because we learned that the solution is exactly where the graph crosses the x-axis. So these are my solutions. +3 and -4. That's what that would look like if we sketched a graph on those, okay? If we have a negative discriminant, that means that we're going to have two complex. Remember when we use the word complex, that just means that it's got an imaginary number in it. Two complex solutions. Two complex solutions. These are irrational. These are irrational. And these are also unequal. So I'm going to write the same thing. Solutions are not equal. And I'm going to show you what that looks like. That is something like 2 plus or minus 3 root 2. Because that means that I have 2 plus 3 times the square root of 2, or 2 minus 3 times the square root of 2. That's irrational because I have a radical in my answer. They're definitely not equal to each other, right? 2 plus 3 root of 2 does not equal 2 minus 3 root of 2. So what do these look like? Well, these are above the x-axis. So my graph could be something like this, or my graph could be something like this. It's never going to touch the x-axis. It's never going to touch the x-axis. That's why it has an imaginary solution, okay? That's why there's a negative under there. They don't touch, okay? What about if it's just what if it's just not a perfect square? Well, that's just going to have two real irrational solutions. The solutions are still not equal. The solutions are still not equal. And I need to add an I to this guy right here. This complex guy needs to have an I added to it. 3I root 2. Throw an I in there. You see how I squeeze that in there? 2 plus 3I root 2. Because if it's negative, it's got to have an imaginary root. And if it's not negative, but it's not a perfect square, it can just have an unperfect, like 2 plus or minus the square root of 5. Same thing, though. These do the same thing, right? Because they are not nice whole numbers, but they actually have value. We can actually we can have our solutions actually touch the x-axis, right? They're real numbers. They're real numbers. We can see them on the x-axis versus an imaginary solution. And then if it's 0, if your discriminant is 0, we have two real rational solutions. And the solutions are equal to each other. It's like x minus 3, the quantity squared. Well, that just means x minus 3 times x minus 3, which means your solutions are x equals 3. X equals 3, right? It's the same thing. And on a graph, that looks like a bounce. It's where your graph just touches the x-axis. It just bounces along the x-axis. It could open upwards or it could open downwards, but it just bounces. It just makes a bounce. Okay. This is page 6 of your notes. Okay. So we have some examples. We have to find the discriminant and then use that to tell how many solutions there are going to be, what kind of solutions they are. So first thing that we want to do is make sure when we're finding the discriminant that our quadratic is set equal to what? Yeah, first thing we have to do is make sure that our quadratic equals 0. Our quadratic equals 0. Okay, so 3x squared plus 2x. What do I have to do to make this equal 0? Subtract a 1. So I'm just going to write minus 1 equals 0. Let's figure out the discriminant. What is b squared? Well, what's the value of b? 2. It's not x. So 2 squared minus 4 times what's the value of a? And what's the value of c? Okay. So 2 squared, well, that's 4. I have 2 negatives here. Do you guys see that? A negative times a negative is going to be a positive. 4 times 3 times 1 is 12. So what is the value of my discriminant? It's 16. So is 16 a perfect square? Is it negative? Is it a not perfect square? Is it 0? It's a perfect square. This is a perfect square. 16 is a perfect square. If you look at your times table, how do you know 16 is a perfect square? You can find it along the diagonal. This says how many complex roots am I going to have? Well, complex roots means that it's going to have an imaginary, right? Some kind of imaginary number. And that only happens when your discriminant, the number under the radical, is negative. Do we have a negative value in our discriminant? What is the value of the discriminant? It's 16. Is that negative? No. So we have 0 complex roots. Okay. Well, are the roots real or imaginary? They're real. The roots are real because if they're not complex, if there's not a negative under there, then it's not going to be imaginary. Are the roots rational or irrational? What does it say under perfect square factorable? It says our roots are rational. Oh, poop on a stick. It says our roots are rational. Okay. Can the original quadratic be factored if your discriminant is a perfect square? Yes, it's in the factorable column. Yes. Okay. Let's do another one. Okay. Is this written in standard form? Is it set equal to 0? No, it is not. How do I set this equal to 0? Subtract 3. So I get negative 6x squared plus 3x. And 2 minus 3 is what? Negative 1 equals 0. So let's find the value of the discriminant. What is b? So it's positive. So 3 squared minus 4 times what's the value of a times what's the value of c? Okay. How many negatives do you see getting multiplied together? 3. So I really have 9 minus, let's see, 4 times 6 is 24. What is 9 minus 24? It's negative. Yeah, good job. It's negative 15. So I know that if I have a negative number in the discriminant, that's a negative number under your radical. That means that you're going to have a complex root. And I told you yesterday that complex roots happen in pairs. They happen in pairs. So if you have one complex root, that means you really have 2. So anytime you have a complex root, you have 2 of them. It'll be posted. Okay. Are the roots real or imaginary? Well, what does it mean to have a complex root? It means that you're using I, which is an imaginary number. Are the roots real or irrational? Well, anytime you use I, that's irrational. Can the original quadratic be factored? No, you cannot factor when your discriminant is a negative number. You cannot factor that. Is this making sense? A little bit. Okay. Let's look at example number 3. So for example number 3, it says that we have to find the discriminant, but what do I have to do with my quadratic first? Is it in standard form? Set it equal to 0. Do that for me. Tell me what that's going to look like, Tyler. Yeah. Plus 20x, right? Because I'm going to add that 10x over to the other side. Plus 25. Okay. Equals 0. Thank you. Let's find our discriminant. What's B? So 20 squared minus 4 times A, which is 4, times C, which is 25. All right. So let's see. 20 squared is 400. And it's going to be a minus because there's only one negative. And 4 times 4 is 16. And 16 times 25 is 400. So what is 400 minus 400? It's 0. Okay. So that just means that you have some value of B plus or minus 0. So you just have, this is that double root, right? This is where it's double. So how many total complex roots do you have? Well, you don't have any complex roots because there are no imaginary roots. Are your roots real or imaginary? They're real. Are the roots rational or irrational? They're rational. Can the original quadratic be factored? Yeah, it can. What does this look like on the graph? Remember? This is where it just bounces. It's a bounce, right? Something like that, where it just touches the x-axis. It's a bounce. Okay? Just does a bounce. Questions about that? Are we doing okay? Okay, next one. Find the discriminant of the quadratic equation and comment on the nature and the number of roots, and then find the solution. So here we actually have to solve. Okay, so I'm actually going to work it out vertically because I don't have enough room to squeeze everything in here. So the first one, 7x squared minus 2x minus 5 equals 0. Okay, so this is A. So quadratic formula, let's see, let's do the discriminant first. What is the discriminant? Well, B squared, so negative 2 squared minus 4 times 7 times negative 5. Okay, so what is 2 squared, negative 2 squared? Negative times a negative is a, so I have 4. And then I'm going to take two negatives and multiply them together. So that means I'm going to have a plus. 4 times 5 is 20, times 7 is 140. Well, what is 4 plus 140? Is 144 a perfect square? Yeah, it is. So let's solve it. What's the nature and the number of the roots? Well, I know that our new roots are going to be real, right? Because it's a perfect square. I know that they're rational. And I'm going to have 2 roots. And they're not going to be equal to each other, right? 2 roots that are not equal to each other. So when I use the quadratic formula, I just have the opposite of B. Well, the opposite of B is what? 2 plus or minus. We already know what the discriminant is. The discriminant is 144 all over 2 times A. Well, 2 times 7 is 14. What is the square root of 144? 12. So I either have 2 plus 12 over 14, or I have 2 minus 12 over 14. What is 2 plus 12? Say it. It's 14 divided by 14. What is 14 divided by 14? 1. Okay. And what is 2 minus 12? So the next one is going to be negative 10 over 14, which actually reduces to negative 5 over 7. So my two roots, they're real, they're rational, they're not equal to each other. That's right. You're just going to have to use a quadratic formula. You just need to know that. The only difference is that it's asking you about the solutions before you solve it. That's what that whole nature and number of roots, it wants you to know what kind of solutions you're going to have before you solve it. If you can use the quadratic formula and get rid of your, like, simplify your radical, that's really the most important. Okay. Let's do another one. I have B and C to do. Let's look at B. So let's set it equal to 0. Well, it already is. Thank goodness. So B, let's find the discriminant. So the opposite, so B squared, that's going to be 4 squared minus 4 times A times C. You guys with me? You see where I am? So what is B squared? 16. A negative and a negative is a positive. 8 times 4 is 32. So let's see. 16 plus 32 is 48. Is 48 a perfect square? No, it is not. 48 is not a perfect square. It's not a perfect square. So what happens to your non-perfect squares? What kind of roots do you have when you have a non-perfect square? You have two, what does it say on the front side? Two real irrational. Yeah, because we're going to have to simplify the radical. Two real irrational roots. Okay. Two real irrational roots. Well, let's figure out what they are. So the opposite of B, that's negative 4, plus or minus. We already know that the radical underneath it, that discriminant value is 48, all over 2 times A. Well, A is 2. 2 times 2 is 4. All right, so how can I break up the square root of 48? Will did it earlier. What did you just say? 16 and 3. Good job, Garrison. Negative 4 plus or minus the square root of 16 times the square root of 3 all over 4. But what is the square root of 16? Say it. It's 4. So this really equals negative 4 plus or minus 4 root 3 all over 4. Can I simplify this? Yes, I can. Negative 4 divided by 4 is negative 1. Positive 4 divided by 4 is a positive 1. So I have the square root of, I have negative 1 plus or minus the square root of 3. Those are my two solutions. Negative 1 plus the square root of 3 and negative 1 minus the square root of 3. That's irrational because there's a radical in the denominator. Or not, because there's a radical in the solution. Example C. Example C. Is this one in standard form? No. How do we put this one in standard form? Do it all. Tell me how to put it in standard form. Do it all. What has to come first? It's negative 5x squared, right? Negative 5x squared. Keep going. I have to move that negative 7x over to the other side. So I add it. What's 7 plus 3? 10x. Move that positive 6 over. So it's going to become a minus. Equals 0. Okay, let's figure out the value of the discriminant. B squared. Well, that's 10 squared. Minus 4 times A, which is negative 5, times C, which is also negative 5. So this gives me 100 minus, because I have 3 negatives. 5 times 5 is 25, and 4 times 25 is 100. Well, 100 minus 100 is 0. Okay? So when your discriminant equals 0, what kind of solutions are you going to have? Well, you're going to have two solutions. They're going to be real and they're rational. They're real and they're rational. Rational is just something that's written as a fraction, doesn't have anything weird like a square root in it. So let's see. What is the value of b? B is 10. So the opposite of b, negative 10, plus or minus. Well, the square root of 0 is just what? What is the square root of 0? It's just 0. Who said they don't know? Tyler, silly. 2 times a, that's going to be negative 10. 2 times a is negative 10. Okay? So when I simplify this, I have negative 10 plus 0 over negative 10. And I have negative 10 minus 0 over negative 10. I heard you say that. What did you say, Tyler? Oh, I thought I heard someone say it. Someone said an S word. Okay. What is negative 10 plus 0? And what's negative 10 divided by negative 10? It's 1. What is negative 10 minus 0? And what's negative 10 divided by negative 10? It's 1. So if you look at it, it says when you have a 0 in the discriminant, you're going to have 2 real roots and they're equal to each other. That means that this just bounces on the graph. This is just a bounce on your graph. That's page 7. Okay, we have 2 more examples, 3 more examples. Yeah, you try on the back. You try. No, because I have to do the ones on the bottom. Sure you can. Set it equal to 0. Set it equal to 0. Find the value of the discriminant. You'll be all right. Sir. You would. You're going to move that negative 3x over to the other side. So it's going to be actually a positive. You're going to add 3x to both sides and minus 3 from both sides. Okay. What do you guys get for the value of your discriminant? Negative 108. So if I have a negative number under my radical, that tells me what? That I'm going to have 2 complex roots, right? 2 complex roots. Well, you can't add those. How many negatives do you have there? Where did you get 2 negatives? You should have ended up with 4x squared plus 6x plus 9. Okay. So you have 2 complex roots. So we have to simplify this. We have to put it into the quadratic formula. So b is 6. So the opposite of that, negative 6 plus or minus the square root of negative 108 all over 2a, which is 8. So is 108 divisible by a perfect square? Well, it's even. 9. Is it divisible by 9? Yeah. And I heard you say 12. Is it big? Is it divisible by something bigger than 9? Bigger. A bigger perfect square. What's 5 times 5? What's 6 times 6? Is 108 divisible by 36? Yeah. I think it is. Why don't you check it? By 3. So notice that I pull out my I. Why can I pull out an I? So what's underneath the radical? It's because of the negative, yeah. And then I'm going to write this as the square root of 36 times the square root of 3 all over 8. But what is the square root of 36? So this is really negative 6 plus or minus 6i root 3 over 8. Your 6, negative 6, and your 8 are all divisible by 2. Negative 6 divided by 2 is negative 3. Plus or minus 6 divided by 2, 3i root 3 all over 8 divided by 2 is 4. That's your answer. That is a little scary. We're going to do, like, if you think of those in terms of like right side, left side, we're going to do the 2 examples that are stacked on top of each other on the left side. The 2 examples on the left side. So you need it when you do math 3 to graduate. And then you use this when you, if you do anything with engineering, any kind of, so hang on a second. What is this shape that we're using? A parabola, right? That's what a quadratic is. It's a parabola. How many parabolas are there in real world? Well, have you ever hit a volleyball up in the air? What does that make? What is a volleyball? Makes a parabola. Have you ever kicked a football? What does that make? Which is a parabola. Okay. What if you are trying to figure out how far you, like, you're on this side of the Golden Gate Bridge and I'm on this side, and we want to figure out if we walked across the top, how far that would be if we know the distance across the bridge this way. That's a parabola. All of those. So there are parabolas all over in real world. So anytime you're trying to calculate distance of a curve, right? Anything that has a curve, and like very little of our real world is like nice straight lines that you can set a ruler to. So any type of curve is going to have imaginary numbers. The difference is that once you get into engineering, you're going to learn that there are programs, right, that you can actually like measure with a camera, or like you can take a video and it'll measure, and then it'll calculate like your gravitational and your vertex and all of that for you. But you're not going to be able to get a program like that until you understand the math behind it. So any kind of basic engineering or basic construction uses parabolas. How many of you guys have an arch on your house? Any curves at all on your house inside of it or anything like that? Yeah, most if you have like a throughway going from like your living room to your kitchen, I would say 50% of those are like arched. That's all a parabola. So they have to know how to cut the wood, right?
I mean, I just freehand it, let's be honest.
That's good. I love that. Okay, let's do these last 2 examples. How do I solve this? This is very basic. What method can I use to solve this? I don't need to do anything crazy. Shh. I have no idea what you're talking about. How do I solve this? Shh, I see it. What am I going to do? No, I don't want to add 3 to the other side. Can't I just take the square root of both sides? Yes. What happens when I physically draw my own square root? What do I put in front of it? A plus or minus. And the square root of -3 is the same thing as the square root of -1 times the square root of 3. But what is the square root of -1? So this is really x equals plus or minus I root 3. Why do we put a plus or a minus in there? Again, because this is a parabola. And remember, when you think about this, this is the distance, right? This is how far apart it is. It touches the x-axis 2 times, on the positive side and on the negative side. Okay? Now, last one. What are we going to do here? Subtract 3 from both sides. I want to use the square root method on both. Let's subtract 3 from both sides. So I have -2x squared equals 10. Now what? Well, I got to get x squared all by itself. Divide by -2. Divide by -2. So x squared equals -5. Now what? Square root of both sides. Square root of both sides. So x equals a positive or a negative. What can I pull out of my radical? I times the square root of 5. Okay, I'm just telling you guys, if your notes aren't filled out, you're not going to the restroom, so don't ask me, just so you know. Shh.